students, selamat sejahtera. Today we will be discussing Muafakat set 2 scheme. Question 1a, limit when x approaches negative infinity for the given function. For the question, when x approaches negative infinity, we have to have negative outside the set, and then we divide every term with the highest power of the denominator, which is x. So the denominator will be divided by x, and the numerator will also be divided by x, but in this case the numerator has set, so it should be written as set x squared, because set of x squared is the same as x. So we will get 1 mark here, and then we substitute and simplify, you get another mark. Okay, because this one will give you 0 and this one will give you 0. This one will give you 1. This one will give you 7. And then final answer, we will get J1. Question number 1b, we are given of gx function. So in this question, gx is continuous at negative infinity to infinity. So this means gx must also be continuous at 2 and 5. So we look at the condition one by one. If the function continuous at 2, limit must exist at 2. So if limit exists at 2, we have here 2 minus and 2 plus. So we will be using these two functions. Now we write 2x is equal to 5x plus m, and we substitute, because limit exists, so we just can substitute 2 inside the equation. So 2 times 2 here, and here 2, so you will get 2m. So you simplify, you will get 4 equals to 2m plus n, so you will get the first K1. And then second condition, the function is continuous at 5. So if you look at the question, if limit exists at 5, so 5 minus and 5 plus should be the same. Okay, so we have the second function is the same as the second function. Yeah. And then we substitute 5 at both x. Here we substitute 5, here we substitute 5. Okay, because limit exists at 5. So we will get 5m plus n equals to 3 minus 5, and we will get our second equation, that is 5m plus n is equal to negative 2. This is our second K1. And then for both function, we do simultaneous equation. Okay, we will get K1, you get your answer for m, for your first J1, and then your answer for n is another J1. Question 2a, to differentiate y equals to ln set of xy first step is to use log theorem. This one, log AB equals to log A plus log B. So we get this one, ln set x plus ln y, and then you put half in front. This is power theorem. This is power theorem. And then you differentiate. You get this one. And this is implicit differentiation. Differentiate ln y. You get 1 over y dy dx. You will get your first mark. And then you make dy dx your subject. You will get another mark. And then you simplify until you get dy dx y over x to y minus 1. You will get j1. Then you will find x by substituting this given in the question into your original function given in the question also. You will get e to the power of 2 is equal to x. So this one we will get k1, and then substitute both y equals to 1 and also x to the x e to the power of 2 inside this. Okay. So you will get dy dx is equal to 1 over e to the power of 2. This one is given when you substitute y equals to 1 and x equals to e to the power of 2. Then j1 is given for the final answer. Okay, for question 2b, the question is y equals to e to the power of negative x cos x. You want to differentiate it, so you use product rule. You will get k1. Then you simplify by, then you factorize negative e negative x, and then you simplify because you want to find the second derivative. Once again you use product rule. You will get another k1. Then simplify. After that you substitute x equals to 0 in the first derivative. Substitute, you get k1. This is where you substitute. Get k1, and then get j1 when you get your answer 1 for first derivative, and then get your answer 0 for the second derivative. You will get your j1. For question 3a, you are given the volume of a sphere. The volume of a sphere. So you have to differentiate. So you differentiate, you get k1. Differentiate implicitly, okay? Because you differentiate v cannot, so you have to have over dt, and then you differentiate r to the power of 3. Okay, you will get 3r2 dr over dt. You cannot differentiate r with respect to dt, so you have to write dr over dt. Okay, and then given in the question is dv over dt is 150, and also in the question given r is 50. You substitute both here, you will get another mark k1, and then final answer is j1. So 3 marks altogether. So for question 3b, given the area over the area of the surface of the sphere. Okay, area of the surface of the sphere. Okay, you differentiate implicitly again. Okay, because you have differentiate a with respect to t cannot. So a dA over dt, and then for pi put back, for pi, then they want to differentiate r squared, you will get to r. Then because you want to differentiate r respect to t cannot, because this is r, you have dr over dt. Okay, implicit. So you will get k1, and then given this is what we calculate earlier at a. Okay, and then this is given, so you substitute 50, and this one, because you calculated earlier, you get k1. So k1 is here, not here. K1 will be here. Okay, k1 will be here. So your answer is 6, j1. Okay. Now we go to section B, 1A. We want to sketch the complex number z on an Argand diagram. So we have to sketch this diagram. You have to sketch the x-axis and y-axis that represent real number and imaginary number. You have to have the value of -24 and -7. You have to have this point, and also the line that represent complex number z. Then you will get 1 mark. Okay, for question 1b, the question wants you to calculate argument z. So before that, you have to calculate alpha, which is this small angle. So for that one is inverse tangent of 7 over 24 without the negative. So you will get alpha as 0.284. You will get another mark here, and then you calculate the argument, which is this one argument. The calculation is negative pi minus 0.284. You get another mark, and then the answer is negative 2.86 or negative 0.91 pi radian is another mark. For 1C, you want to calculate A and B for complex number W. Okay, what you want to do is actually use the polar form. This is the polar form. Okay, R is given that is 4, and theta is given 5 pi over 6. So this is given, this is given. So you just use it and substitute it in the polar form. But if we use cos 5 pi over 6. 5 pi over 6 is actually cos 150. It will be on the second quadrant. So for cos 150, second quadrant is negative. Negative cos of 30, the reference angle. So if you use special angle 30, this will be 213. Negative cos 30 will be negative cos negative 3 over 2. Okay, that's why I put it here. But for sine 150, sine on the second quadrant is still positive. So sine 30 for special angle will be half. That's why I have half here. So you will get your K1. Okay, J1 is your value for A and value of B. Okay, this is A, this is B. So you get here J1. For 1D, we want to find modulus of Z times W. We use the formula or properties of modulus of Z times modulus of W. You will get K1. And then you calculate modulus of ZW, set of negative 24 squared plus set of negative 7 squared, multiply with modulus of W given for, you will get K1, and then in answer 100 you will get J1. For question 3a, we want to find f of g and g of f. So if we calculate f of g, we will get x. Substitute gx inside f function, we get x. And then to find g of f, substitute function fx inside g. Okay, you will also get x. Marks will be given 5. Okay, this one you will get K1. You get x J1. Then for gfx, you substitute here, you get K1. You get another x, you get J1. And then conclusion, f x and g are inverses of each other, J1. It's either that you say f and g are inverses of each other, or you can say f is the inverse of g, g is the inverse of x. The statement is the same. So 5 marks altogether for 3a. 3b, you want to find hx. When given hx is equal to f2x plus 3, so you substitute function f inside function h. Okay, you get K1, and then the answer ln for x plus 5 J1, 2 marks. And then C, find the composite function of g of h. Find this one, means you substitute function h inside g. So you get K1, and then the answer will be J1, 2x plus 3, 2 marks. And then question D, you want to find h inverse. So you use h inverse equals to x, substitute h inverse inside h function. Okay, you get K1, and then you get h inverse e to the power of x minus 5 over 4, another J1. that is to find H inverse. Sketch both graph on the same diagram. I choose to sketch exponential function. So when I calculate the y-intercept and asymptote, I will get k1. Okay, and then when I sketch the graph, I sketch one correct graph, I get R1. I get another correct graph, I get another R2. Okay, and then both correct, I will get another one. Okay, the graph will be if I sketch H inverse, the graph should start from first quadrant, and then the intercept is at -1. Okay, graph is at -1, and then cannot touches -5/4. Cannot touches this. In this case, because the intercept is below y equals to 0. Okay, so it should cut y equals to x. Okay, for question 2a, we want to solve the equation by using substitution of this one. A equals to e to the power of x. So what you have to do first is to split the exponent. This exponent we have to break up into 2, which is x and ln 2. Okay, and then for this one, because it has negative, so put it below, write it as ratio. Okay, 15 over e to the power of x, so that this one will be a, then this one will be a also. So you split the exponent and put it down, the second one, we will get k1. And then you simplify. Next mark will get next mark you will get when you get quadratic. Okay, then you factorize, and then this one is k1, not j1. K1. When you get your answer, your A, you will get your third mark, J1. And then you substitute back your A as e to the power of x. Both, another k1. And solve using ln on both sides. Marks will be given for the answer ln 5/2 and also undefined. Why is it undefined? Because log cannot be negative. Cannot be negative. We don't have ln of -3. If you use calculator, it will be either syntax or max error. So this J1 is for ln 5/2 and undefined. If you don't write undefined for the second term, you cannot get J1. Okay. Okay, for question 2b is absolute values inequality. The first mark will be given if you write this one exactly both, but if you don't write this one, never mind. Don't write, never mind. It's okay, never mind. Okay, for B1, you only have this part dengan this part. Okay, you will get B1. Next is K1. K1 is either one sebelah is when you bring to the other side. And then another K1 is also either one. You don't have to do both. Is when you take common denominator. Okay, common denominator. Next mark will be this one, K1. Also either. Either one. But make sure the sign is correct. K1 is also either one. K1 is either one. Either one correct, the table. Okay. K1 should be like this. Okay. Union. Okay. And then J1 will be in solution set. Exactly like this. Okay. That's all. For question 3a, we want to find f of g and g of f. So if we calculate f of g, we will get x. Substitute gx inside f function, we get x. And then to find g of f, substitute function fx inside g. Okay, you will also get x. Marks will be given 5. Okay, this one you will get K1. You get x J1. Then for gfx you substitute here, you get K1. You get another x, you get J1. And then conclusion, f x and g are inverses of each other, J1. It's either that you say f and g are inverses of each other, or you can say f is the inverse of g is the inverse of x. The statement is the same. So 5 marks altogether for 3a. 3b, you want to find hx. When given hx is equal to f2x plus 3, so you substitute function f inside function h. Okay, you get K1, and then the answer ln for x plus 5 J1, 2 marks. And then C, find the composite function of G of H. Find this one, means you substitute function H inside G. So you get K1, and then the answer will be J1, 2x plus 3, 2 marks. And then question D, you want to find H inverse. So you use H inverse equals to X. Substitute H inverse inside H function. Okay, you get K1, and then you get H inverse e to the power of X minus 5 over 4, another J1. That is to find H inverse. Sketch both graph on the same diagram. I choose to sketch exponential function. So when I calculate the y-intercept and asymptote, I will get K1. Okay, and then when I sketch the graph, I sketch one correct graph, I get R1. I get another correct graph, I get another R2. Okay, and then both correct, I will get another one. Okay, the graph will be if I sketch H inverse, the graph should start from first quadrant, and then the intercept is at -1. Okay, graph is at -1, and then cannot touches -5 over 4. Cannot touches this. In this case, because the intercept is below y equals to 0. Okay, so it should cut y equals to x. So we want to find the vertical asymptotes of the function given. Okay, this is the function given. Okay, so first we want to take the denominator as equal to 0. Okay, that's when we get x equals to -1 or 3. Okay, this is the way how to find vertical asymptotes that we know. And then we want to test. Okay, our target is to find the limit when x approaches -1 plus minus and x approaches 3 plus minus, so that all the calculation will get either positive or negative infinity. That is to make sure that it is a vertical asymptotes. So we go to the first question. First one, I calculate x approaches positive and -1. So in this case, for -1, if we look at the function, okay, for other factor such as the numerator, okay, numerator is 2x plus 2x minus 3 and x minus 3, we just substitute in -1. -1. The only term that we substitute -1 infinity is this one. Okay, that's why I get the numerator, I get -5. Okay, because I substitute -1, and then I get this positive. I don't write number, never mind. Okay, just write positive, because -1 minus 3, I will get -4, right? So that's why I put negative. Okay, the only term I substitute with -1 negative is this term. Okay, this term. So I will get 0 minus. Okay, how I do that, I have taught you, right? I show you again. So let's say I have 0 and -1 here. So if I have -1 minus, is this here, -1 minus is on the left hand side, and then plus 1 according to the question, plus term plus 1, I have to go in front. So it should be 0 minus. Okay, it stops on the left hand side, so 0 minus, or I get 0 minus here. So when I multiply negative number with a small 0, I will still get 0, but because I have two negatives, 0 negative and negative number, I will get 0 positive. Okay, that's why when I divide upper numerator negative, denominator positive, I will get negative infinity. Okay, the same calculation goes to every step. So for the same goes to when limit approaches negative 1 positive infinity, I will get positive infinity. So for this both calculation, I will get k1, and then for limit when x approaches 3 minus, I will get negative infinity, and for 3 plus, I will get positive infinity. Okay. Take note that the negative that I wrote here is actually a value, but I just put negative positive there. Okay. So we can assume that vertical asymptotes are at x equals to 1 and x equal to 3. According to what we calculate, both I get infinity. It doesn't matter whether negative or positive infinity, as long as it is infinity. Okay, so assumption, we get J1. So for horizontal asymptote, we just calculate limit for the function. Limit for the function, okay, so positive ke negative ke, or you don't write also can, never mind. Okay, the calculation will be the same. Divide, you write the function, you write the calculation of limit, and then k1, and then you divide every term with the highest power of denominator, and you get your answer. So you get J1. So horizontal asymptote is at x equals to 0. Okay. If you don't want to write this one, you can put here y equals to y equals to y equals to y equals to. Okay. So kalau macam gini, ini J1. You tak ada ni pun tak apa. Tapi kalau tak tulis, you can tulislah horizontal asymptote is at x equals to 0. Okay, for question number 5, we are given a piecewise function. The question says that we want to find the continuity at x equals to 2 and n at x equals to negative 2. So we go for the continuity at x equals to 2 first. So we calculate f2. So f2 is, we use this function, so it is set of modulus of x. So modulus of x, so modulus of 2, so our answer is 2. And then for the limit, okay, if we want to find the continuity of 2, we have to find the limit at 2 plus and also 2 minus. So we start with 2 minus, limit at 2 minus, okay, x of modulus x, because 2 minus is modulus x. Then we substitute 2 inside x, so it will become 2 set of 2, so the answer is 2. And then we calculate limit of 2 plus. Just now 2 minus, just now is 2 plus. Okay, so 2 plus we use this formula, 2 minus x to the power of 3. Okay, use this formula. So we substitute 2 minus 2 is 0. 0 to the power of 3 is 0. So we get different answer. One is 2, one is 0. So it is not the same. Limit 2 plus and 2 minus is not the same. 1 is 2, 1 is 0. So limit does not exist. So we conclude that the function is discontinuous at x equals to 2 because limit does not exist at 2. Okay. To look at continuity at 2, negative 2, so we calculate f negative 2 is what? So by using the function from the graph, x equals to 2, here 2x equals to 2, negative 2, sorry, negative 2. Okay, we use 4 plus x. So you use 4 plus x. Our x is negative 2. So 4 minus 2 is 2. So 4 negative 2 is 2 for the function. And then we have to calculate the limit. Limit from negative 2 minus and negative 2 plus. So we have to find for the function limit when x approaches negative 2 from negative. So negative 2 from negative will be 4 plus x. So that's why we have 4 plus x here. And then we calculate 4 plus negative 2 is 4 minus 2 is 2. Then the other one is x, when find the function for limit x approaches negative 2 plus. So negative 2 plus is modulus x. So that's why we have modulus x here. So substitute modulus x as modulus negative 2. So negative 2 modulus will be 2. So if you look here, the answer will be the same for negative plus or negative minus. So because it is the same 2, so limit exists at x equals to 2. And then you look here, number 1 is the same as f negative 2 is the same as the limit when x approaches 2, that is equals to 2. So we have to conclude that the function is continuous at x equals to 2. Number 5, marks given when we calculate continuity at x equals to negative 2 first. Okay. Is Q1 if you calculate f negative 2, and then another Q1 if you calculate the limit and you get 2, then you equalize limit 2 plus 2 minus is equal to 2. Actually you do this also, you dah boleh dapat markah K1 and then G1 you state that fx is continuous. For continuity at x equals to 2, this 2 baru dapat K1, and then we state that fx is discontinuous, we get G1. So altogether 5 marks for the first part of the question. We haven't discussed sketching of the graph yet. Question 5 for graph sketching. We sketch the y and x axis first, and then we put all the values of x on the graph, which is -2 and 2. So we put -2 and 2, and then we calculate f -2 according to the function given. So f -2 for 4 minus 2 4 minus 2 is 2. Then we put on the graph point -2, 2, point -2, and then it is black dots. And then we calculate f -2 again for this function. So you will get 2. In this case, also -2, 2, but white dots. But the white dots is intersect with the black dots, so it will still be black dots. And then for f2 for the same function set x, you will also get 2. So this will be 0.22, also black dots. 0.22 is here. And then point f2 again, but in this case you substitute into the last function, you will get 0. So the point here is 20. It will be white dots. So okay, next what you do is to sketch the graph. First, the easiest one is the this is the linear function. 4 plus x is a positive graph. Positive graph should be like this. Okay, so this is the graph lah. So it will cut at x-axis, which is y equals to 0. So you calculate, if y is 0, x will be -4. So it will cut the y-axis, x-axis at -4. And then from -2 until 2, you have a modulus. So you just sketch your modulus graph like that, V-shape modulus graph. And then lastly, from 2 above, but starting from the white dots, not the black dots, white dots, you have to sketch quadratic function, negative quadratic function, because in front of the x is negative. So if positive quadratic function is like this, so negative quadratic function is the other way around. This is the negative quadratic function. So we have to sketch the blue graph. So this is the quadratic function. So you get your answer. Now you already get your graph. Okay, so this is your graph. Hilang kat sini. So this is your graph. Yeah, you will get marks for your linear graph, your modulus graph, and your cubic graph. And if all correct, you get another 1 mark. For graph, it will be 4 marks altogether. For question 6a, we have to differentiate the function, okay, by using implicit differentiation. But before that, you simplify the function first by using a log theorem, which is for this one, this is a power theorem. Sorry, this is a product theorem. Okay, and 3 bring in front, okay, to become this one is a power theorem. So we will get K1 if you use the logarithmic theorem, and then for the second K, for the second mark, you differentiate implicitly. Y squared becomes 2y dy dx. This one is a normal differentiation. Put 3 and then differentiate ln x, you will get 1 over x. And then this one also differentiate implicitly, you get K1. After that you simplify and factorize dy dx. Okay, you get another K1, and then you simplify to get dy dx as this. Okay, you will get G1. So altogether you will get 4 marks for 6A. For question 6B1, you are going to do parametric equation. You are given x in the terms of t, so you find dx dt. So this is what you get, and then you will get 1 mark. Next, you will be given y in terms of t, and then you differentiate dy over dt, then you get another mark. This is what you get for dy dt. Okay, and then you find dy dx by using chain rule. Okay, by using chain rule, you will get K1, and then this is the answer for the chain rule. And to show that the answer is 1 minus 2 over 3 squared plus 1, you have to do long division. So you do long division, you get K1. Yeah. You do long division, you get K1, and then you get 1 minus 2 divided by 3 squared plus 1 shown, you get G1. Okay, for question 6B2, the question wants us to deduce from A to B. So we should start from this part. Okay, because t squared can never be 0, plus 1 should be greater than 0. So when we put 2 as the denominator, 2 divided by 3 squared plus 1, which is greater than 0, should also be greater than 0. Okay, when we put negative in front, we change the sign, and then we put 1 on left hand side and right hand side. So this one will become dy dx. So dy dx is greater than 1. So 1 mark is given here. And another mark is given here. So just K1, G1. Okay, for question 6B3, we want to find the second derivative when t is equal to negative 1. So we start with the first derivative. This is your first derivative. We differentiate implicitly because we want to differentiate with respect to x, but our term is in t. So we do quotient rule here, and then times with dt over dx. Okay, so so we get 1 mark for implicit differentiation. And then when we get we simplify, and then we substitute what we get here with t equals to -1. So we substitute what we get k1, and the answer -1/2 is j1. Okay, for question 7a, a cylinder is inscribed a sphere of radius 5. That's 5. And the height of the cylinder is h, and the radius of the cylinder is r. Okay, the question wants you to show that the volume is as given. Okay, the volume for a sphere is V equals to pi RH, pi r squared h. Volume of cylinder. Okay, we want to eliminate the r here. Okay, so what should we do? Okay, we should find a function where r is the subject. So what we do is take the triangle inside the cylinder, take it out. So this is the radius of the cylinder, this is the height of the triangle, h divided by 2 because this one is h altogether divided by 2 into half. So we will get this is 5, the radius of the sphere. So we use the Pythagoras, r squared plus h over 2 squared equals to 25. So we will get r squared equals to 25 minus h squared over 4, and then we substitute in the r here. So this is it. Substitute and you simplify, you will get what you want to show. So marks will be given for using the Pythagoras, 1 mark, and then to show is another mark, 2 mark. For 7b, we want to find the maximum volume of the cylinder. So we use the formula that we showed just now. We differentiate, but before that I want to simplify. Before I differentiate, after I've simplified the function, I differentiate it. Okay, so then I will equalize with 0. I differentiate, I will get 1 mark here, and then equalize with 0, and then I will get my h. This is my h, so I will get another mark, j1. So I will get 2h. So one will be minimum, one will be maximum. So I use the second derivative test, okay, to know which is the minimum and maximum. So I differentiate, I get my term. Okay, that was not simplified, this one. Then I put my h, one is positive, one is negative. So the maximum is the one that gives negative answer. So that is maximum Q1. So 10 over 3 will give maximum volume. So I substitute. So I get another mark here, K1, for using derivative test. For using second derivative test, and then I substitute K1. I substitute X inside my volume equation. I will get K1. Substitution, you get K1, and then the answer I will get another mark 302.20.